Okay, Tim Sutton. I'm doing an instructional video for my basic tool matrix. I'm going to prep this piece of poly to test the milliamp signal on this Drexel brook. So this will be for identifying how to dress my poly and put proper size ferrules on this poly. So this will work for that piece. Okay, things you'll need to dress this piece of poly. First, you'll need a insulation stripper. You'll need a ferrule crimper, possibly a side cutter, 2 ferrules because this is a 2-wire sensor and you do not hook the shield up, and we're not going to put a bulgeon on the end because I'm going to use it for testing purposes only. And we will need wire strippers. First thing I want to do is take my insulation stripper, take about 2 inches, turn it around a couple times, bend your wire just a bit to make sure everything's broke off, and there you go, properly stripped poly. Now, considering this is a 2-wire system and we don't want any grounding issues in the ultrasonic, we want to cut the shield wire, the green wire, and the red wire off. This will be going into the inside of this ultrasonic. These are unused wires. However, at the bulge side, you want to hook the 4 wires up so it is properly QC'd. But for this side, I do not like grounding issues, so we cut them off. Make sure when you cut them off that you don't catch the black or white wire and cause a corrosion issue. Black and white wire. This is 18 gauge wire, so what we want to do is make sure we find the 18 on the stripper. Strip a little bit back so we have something that looks like that. Same thing as this. There you go. Take your 2 ferrules, 18 gauge ferrules, which are the yellow ones, and you slide them on. It should slide down to the individual wire shield and not go any farther. If it's some on the top, you can just, after you're done crimping your ferrules, you can trim it off. Take your ferrules, run it down to the flush of the yellow plastic, and crimp it. Make sure you give a pull test to make sure it's crimped correctly. If it pulls off, find another ferrule and crimp again. There you go. Okay, sometimes you get a little extra. Try not to do that because it causes problems with the bulges, but you can sit there and trim it off just like so. And that is how you connect crimp 18 gauge ferrules onto poly. Okay, this is the other end of the this is the other end of the poly that I have dressed to demonstrate the milliamp, how to show frequency of the Drexel book. I'm going to dress this side just as well for another set of evidence. This will connect to the DAC after I'm done cleaning it out. So, again, we take the insulator stripper, twist it around a couple times, pull the insulation off. Okay, if this was a bulgeon, QCA standards is black on number 1, white on number 2, green shield on number 3, and green on E. No red wire. The possibility if you hook them together, I know a lot of people do, but you can have a dead short, which will cause you problems. So, take your wire strippers, 18 gauge again, and strip it. So it looks like so. Nice clean. If you have to dress it up, you do. Grab yellow ferrules because that's 18 gauge ferrules. Correct. Test. Oh, sorry. My mistake. Shield wire is only hooked up through from the first bulge and all the way through the deal. This causes this being hooked up, prevents high frequency interference from electrical items. Do not connect this to the sensor, but all the way through the wires, the bulges, the shield should be connected. So, as per, we will put a bulge and a ferrule on here and hook it into the deck. Again, I'll show you the proper procedure. I'm testing off a source 12, so I will remove these wires and I will terminate these wires. Black for source, ground is our shield is shield, and white is signal. Okay, this is a good time to explain the dip switches. These are the dip switches. We want to make sure this is on the current side because we're using a Drexel Brook, so it has to be current. So we want it on source 12. It starts from 1 to 23, which there's 24, but that one, so we want to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If it's current, it's to the right. If it's voltage, it's to the left.